Welcome to the 12th module of chapter Motion. In this module we are going to discuss some numericals based on the equations of motion, based on the three equations of motion.
A trolley while going down an inclined plane has an acceleration of 2 cm per second square. What will be the velocity 3 seconds after the start? So in this question it is given that trolley is moving along a inclined path or inclined plane. So what will be the initial velocity of the trolley before starting to move? It is at rest, right? So u is equal to 0 meter per second. And it is said that it has acquired an acceleration of how much? A is equal to 2 centimeter per second square. And we have to calculate what will be its velocity after what time? 3 seconds time. So time is also given 3 seconds. When you observe the given data, we could understand one thing, that is, here the acceleration is not given in the SI unit. What is the SI unit of acceleration? Meter per second square. So we can convert 2 centimeter per second square into meter per second. How will you convert it? By dividing with 100. So we will get 0.02 meter per second square. Now you can find out what is V. Out of the three equations of motion, which equation you can use for getting the value of V? From this given data, the first equation, that is V is equal to U plus AP. What is U value here? 0. So 0 plus, what is A? 0.02 into, what is time? 3. So the answer is 0 plus 0.02 into 3 is 0.06. So the answer is 0.06 meter per second. So this is the final velocity acquired by the trolley after 3 seconds. Next question. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of 0.5 meter per second square minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So what is the data given in the question? A train is traveling with a speed of 90 km per hour. That is the initial velocity. The speed is here representing velocity only. Initial velocity u is equal to 90 km per hour. And what happened after some time? Brakes are applied. So what will happen to the velocity of the train? It will be coming to rest. So final velocity will be 0. Velocity of the object at rest is equal to 0. And here it is also said that as it changes its velocity or as it decreases its velocity, it produces an acceleration equal to what? Minus 0.5 meter per second square. This is the given data. And when you observe this data, first thing you have to do is what? You have to convert 90 km per hour into meter per second. How will you convert that? 90 into 5 by 18. This 5 by 18 is for converting 90 km per hour into meter per second. 5 by 18 is a simplified form of 1000 by 60 into 60. So 18 and 90 will be going. 10 and 2 and 10 again will be going. The answer is 25 meter per second. Now you can calculate how far the train will go before it is brought to rest. How far is meaning how much distance it travel. So you should not get confused with how far and how long. How long indicates time and how far indicates distance. Okay. Usually you will go wrong. Children will be going wrong in this type of question. So that is why I told. So how far is the distance? So which equation of motion we can use for getting the distance traveled here? From the given data, you can use S is equal to V square minus U square divided by 2A. From the equation, 2A is equal to V square minus U square. And here what is the value? V? 0. So 0 square minus U is 25. 25 square divided by 2 into minus 0.5, which is equal to what? 0 square is 0. 0 minus 25 square is 625 divided by 2 into 0.5 will give you 1. So minus 1. And the answer will be minus 625 divided by minus 1. Minus minus will be getting cancelled and the answer is 625 meter. So the distance travelled before it is brought to rest is equal to 625 meters.